So, why does space travel matter? A lot of people thinking, well, why should we care about going to space when there's so many problems with Earth, right? So let's talk about that. Why we should care. All right. So, just an overview of what we're going to talk about today. First, we're going to talk about the innovations that come with investing in space travel. And we're going to talk about the resources that you could gain from exploring space. Then we're going to talk about kind of the population arguments. And then for the final point in support of it, we talk about just the exploration. That's going to be the loosest topic, because it's kind of a more emotional one rather than like a super scientific, if you know what I mean. Then we're going to do a little bit of a counter argument that I realized I should put in like couple today. So then that's going to be a very not well formed. That's going to have to be as structured as the other ones in today. So. All right. Also, yes, let's try to keep the chat on topic, guys. So, all right. So first off is the innovation that comes with investing in space travel and space exploration, right? So some of the historic innovations that have come from, this is going to be more NASA. NASA's focus on space travel. So NASA has a program that they have spin-off technologies and spin-off products they partner with companies to give them their technology based off of a variety of things. And
so what does that look like? A car? It looks like a car.
Because
it is a car.
It is a car. Yeah,
it goes in space.
We're gonna get into that. No, this
space car.
This is about technologies that have come from investing in space. All right, so NASA has tracked about, using that program, they've tracked about 2,000 different technologies and products that have come from their research. And so that can range from massage chairs to air purifiers to digital cameras, as you can see. So huge just huge investment into technology that you use every day. So interesting thing about the massage chairs is that that comes from the studying the human body in 0G. And so this company made massage chairs based acupressure massage chairs based off of how the human body what it kind of does in 0G. So that's kind of weird. Anyway, so those are kind of the minor things, but the big things that that might come to the forefront of this discussion are aerodynamics and digital cameras. So aerodynamics are huge coming from NASA because it's not, well, because it also does a lot of plane stuff, because it's the aeronautics as well, NASA, the National Aeronautics and Space Administration. And so they've done a ton of investments and research into aerodynamics, because if your rocket or your plane is more aerodynamic, meaning that it encounters less friction and drag in the air, that means you save on fuel a ton, right? And if your rocket can save 5% fuel, that means your rocket costs 5% less to make, and NASA very much wants to keep costs down because they want to keep getting funded by Congress. So and so that aerodynamics have been introduced into the car market. Have you seen cars from the 1950s versus today? Today cars are way more aerodynamic. Buses used to be just bricks, and now they're mostly still bricks, but they're slightly less bricky. Or trucks, for example, they used to also be like essentially bricks, and now they have the more aerodynamic front. And then most famous thing would be these F1 cars, as you can see. Yeah, Viking.
Does negative gravity exist?
Does negative gravity exist, you said?
Yes.
No, not that we are aware of. Because negative gravity, it would require like negative mass, and negative mass, as far as we are aware, does not exist. However, negative mass theoretically, like the equations governing the universe that the current equations we use to model the universe technically allow for negative mass in some instances. So maybe, but probably not. So no. I'll say just no, it doesn't exist. Anyway, so that's not what antimatter is, Jonathan. Anyway, and then digital cameras, because antimatter does exist. We've made antimatter. Anyway, and then digital cameras come from these CMOS sensors that that NASA made for sensing light for various projects, and essentially, like all digital cameras are evolved from that CMOS technology. So, all right. So that's kind of the historic stuff that NASA's done. Let's talk about what they're currently doing that is important. So a big thing is that they have is in situ resource utilization. And that sounds like not English, right? So in situ means just like in place, and that means like how can we use resources on a Mars mission, for example? Can we use resources from Mars instead of shipping all this metal and all these resources from Earth to Mars? Let's just use the stuff that's already on Mars, and that would be the in situ resources. And then there's the deep space atomic clock. And so atomic clocks are super important because they essentially they're so precise that they don't lose time, like they don't lose seconds at all. So the way normal clocks work is that usually every certain period of time they get off by a second, and that just will add up over time to the point where, oh, now we're off by a whole minute, and oh, now we're off by a whole day. And so that adds up not very quickly, but that adds up to be super important for things like GPS that need to track your exact location using like general and special relativity at the same time, and time is very important for GPS. And so you need atomic clocks, which are very, very precise. They don't really lose time that much. And so a deep space atomic clock is going to even be more precise because it's in space. There aren't anything on Earth where they could lose time from a variety of things like, but if in deep space, or just in orbit of Earth, it won't lose that time. And so I think it is like 1 nanosecond. So for example, for how important this time is, when I'm launching a missile that is like can change course, or I'm tracking it with GPS to make sure I'm hitting the target correctly, 1 nanosecond is like 6 feet or something like that. So 6.8 feet, I think it was. So when you're off by 1 nanosecond, right? That is, 3 nanoseconds. All of a sudden, now you're hitting with the missile, you're hitting the building right next to it, right? So it's very important that you have exactly precise time.
Aren't nanoseconds like really small?
Yes, exactly. But you're also launching a missile from, like, we're launching a missile halfway across the globe. and we're trying to get it through a window. So it's 1 nanosecond is very important. Anyway, then they're also doing a lot of projects with batteries and fuel cells. And so that's going to be really important, right? Because renewable energy sources are not really they're not consistent, right? So it becomes nighttime. The wind sometimes it's not windy out sometimes, right? So it's not consistent. There's not consistent energy production, and so you need batteries. And batteries right now are really bad at storing energy for those uses. And so we need to invest in batteries and fuel cells to somehow get that fixed. And so there's a ton of there's stuff like liquid metal batteries that they're investing in right now, and it's kind of crazy because these are like molten metal being a battery. That's crazy. Anyway, and then there's a green propellant, which essentially just yeah, we probably shouldn't just spew, and every time we launch a rocket, we probably shouldn't spew out tons of greenhouse gases and stuff like that. So maybe it's useful to have more climate and friendly propellants for our rockets. So that would make sense, that we don't want to ruin the environment every time we launch a rocket. All right, then let's talk about the resources in space that are useful to us. So I'm going to talk about here in resource, I'm going to talk about 3 main areas. We're going to talk about the moon, Mars, and the asteroid belt, Apollo.
Isn't there water on the moon?
Oh, we're going to talk about that.
It's like frozen.
Yeah, we're going to talk about it. All right, so yeah, so because those are the most close, that's the most reachable goals right now, are the moon, Mars, and the asteroid belt. So lunar resources. So one of the biggest things on the moon is helium-3, which is pictured here, which is one of, I think, the stable isotope of helium. And then what that means is that that exact configuration of helium with 2 protons and 1 neutron, 2 electrons, well, that's just yeah. Anyway, that is that will not decay into hydrogen at all. And so it's very stable, and that's useful for a variety of things, including being a coolant for that's why it's used for so many industrial uses that there's limits on balloons because we're running out of helium on Earth. So yeah, just look up helium industrial uses and you'll just see a huge list. Yeah. And so but one of the bigger reasons is because it's a noble gas and doesn't react with anything, and it's also very light. It's lighter than air, so that gives a lot of uses for it. And the moon has a ton of it, and Earth is running out very quickly. And then the south pole of the moon has a ton of good stuff for us. So that's where, if we had a moon base, it'd be on the south pole, because of the moon. Obviously, we're not going to have a moon base on the South Pole, on Antarctica, right? That's all right. South Pole of the moon. And so that's because on the South Pole of the moon, there's craters that will edges of craters will see constant solar, constant sunlight. And so if we put up solar arrays there, we don't have to worry about other kinds of energy production because it's just constantly getting the sun. So we're fine.
So if you made an electric rocket, then you could charge it?
We probably can't make electric rocket. I mean, it'd be hard to make electric rockets because they'd need to escape gravity. But I mean, if we did somehow make an electric rocket, yes, we could charge it. But it's also lights or running industrial processes, sensors. It's just everything that needs electricity could just be charged with the solar array. If we had a moon base, we could just run it off those solar arrays. And then also in the South Pole is that water that Apollo was asked about. Um, so turns out we don't think the moon has very good like accessible water. It's mostly kind of like in little frozen pellets scattered across the South Pole. So it's not like in huge ice sheets like it kind of is in on Mars, on the Martian poles, but it's there. It's just hard to get. But that is most of the water is on the South Pole of the moon. So that's probably another reason we would set up there. Then a lot of the metals on the moon, there's a ton of metals, a huge resource of titanium, especially, and also aluminum, which are key metals that in like aerospace stuff. So they're pretty good targets. Um, but the problem with is that a lot of the metals, just almost every metal that's on the moon is trapped in minerals, and so it'd be pretty heavy industrial processes to get them out of those, which is gonna need hydrogen to capture the minerals. So the way it would work is that you would attach a hydrogen molecule to the mineral, and then that would it cause reactions to get the metal ion that you want out of the mineral. But that's really hard and it requires hydrogen, which you might actually be able to farm using that process, but it's just very complicated, as you can see. Like me just droning on about it, you're probably not like getting any of it, and that's why it's so hard, because it's just like complicated to do. And so takeaway, metals, very plentiful, but very hard to get out of the minerals. Then there's the lunar regolith, which sounds super cool, kind of, but it's not like, it's just like the dirt on the moon. It's just kind of like the rock covering of the. It's like the analogy to Earth would be like the dirt on Earth, but it's like not dirt, but you know what I mean, kind
And
of.
it's like useless then.
Well, it contains like rocks and stuff, but the cool thing about it is that people have made using materials that are kind of simulating a similar structure, is that they've made like concrete out of it, so it's called lunar or mooncrete or lunarcrete, and so that's kind of cool. So we could use the for like actually building the base, we could just use the regolith that's on the moon instead of importing stuff to actually construct the base. So
That'd be less expensive. But
it
how do
would
you get the
be,
machinery out?
well, I mean, either way, you'd have to get the machinery out. So it just, it is way cheaper. It's way cheaper. So yeah. Yeah, the big thing that you'll probably see like throughout this resources part is that it gets things like cheaper, and that's because sending stuff into space is prohibitively expensive. It's it is like one of the most expensive things you can do. That's why only billionaires are trying to go to space, because they have literally nothing else they could do with their money except save like poor people, but they're rich, so they don't care. Anyway, that's political. We don't need to get into that. All right. Martian resources. Let's talk about Mars now. So Mars actually has a lot of metals, we think. That's because it has a lot of volcanic activity. And so that is one of the key things needed for that kind of ore to form. And ore is way easier to get the metal out of than minerals, right? So moon, super hard to get the minerals, right?
Wait,
It's
but
trapped.
wouldn't the polar like ice caps at the end would be like poisonous? No, I mean like in Mars. Like is that, I
Yeah,
don't think
but
that's like safe to drink.
yeah, obviously there'd be like other things that they do with it, but there just also is ice there, and that's what matters. So yeah, what matters is that there's liquid water. No, there's not liquid water. There's solid water on Mars, and that's what matters, because we can once it exists, then we can do things to it to make it safe. But what matters is that it exists. Yeah, but remember, so the moon, super hard to get the metals out of minerals. But here, they're in a lot of the time they're in ores, we think, and so that's pretty good. And so, yeah, so so the fact that the volcanic activity, that's just a good sign, but we're not like 100% sure. It's just like, yeah, we think so. Um, and then the soil, it's actually turns out it has aluminum, iron, magnesium, and titanium in the soil with trace amounts of hematite, which is an ore of iron. Um, but so what matters is that those like aluminum, iron, and titanium are some of the most like sought after metals on Earth, especially iron because steel. And so the fact that they're in the soil just is a huge benefit.
So you can like dig out like a bunch of soil and they get like so much.
Yeah, exactly. Um, then there's the large igneous province, which is the lip of Tharsis. And so you have these three major volcanoes, and then a little bit off of Tharsis is which is such a cool name, by the way. Like Tharsis. That's so cool. Anyway, is Olympus Mons, which is the tallest mountain in the solar system, which is a volcano, by the way.
Wait, is that the one in the picture?
Yeah, the top one that's Olympus Mons. So yeah, you would think that like when you think a mountain, you don't think like it just kind of looks like like the surface just got raised a little bit, but that's because it's a shield volcano, which means that it got built up by like a volcanic like thing happened, boom, and then the lava spread out, and then it happened again, and the lava spread out. And so that just happened a ton. So just kind of layer by layer got built. It's like a cake kind of, but of lava. So, but Olympus Mons is technically not a part of Tharsis. It's just a little bit off of the side of it. Tharsis contains three other major volcanoes, but Tharsis is important because it's made up of almost like entirely igneous rock, hence the name Large Igneous Province. And so that means that it's probably very resource rich for metals, and that's why we care about it. Then the polar ice caps have water, probably. Well, they do. However, how much of that is actually like solid carbon dioxide or some crazy stuff like that, we don't know. But we're pretty confident that is a sizable amount of water on the polar ice caps. All right. Then there is the asteroid belt, which is super important for this, right? Because we're gonna get into that more in the fourth day, which is for asteroid mining, which is super cool. But asteroids essentially have like every resource you could want. They have most of them, almost all of them, have ice. A lot, as you can just see on this like table here on the right. Ah, God, sorry. You can see they have like nickel, iron, cobalt, just like ammonia, nitrogen, magnesium, aluminum, platinum, which is just super good because you can see the estimated value of each of those is just enormous, right? So
There's no redstone and diamonds, netherite.
Yeah, there's no redstone because yeah. Oh yeah, I've heard of Randall Monroe, Kiana. He's a pretty cool guy.
Wow, heard of him? I absolutely love his books. Do you know
Yeah,
XKCD?
I love XKCD. That is a great comic.
Wow.
And then, have you read his book What If?
Oh yeah, I've read What If, and he's covered so many crazy scenarios. And I absolutely love that idea in how to. And although I'm not sure if NASA has approved of his idea yet, but if they do, then we might find a big future in space. Yeah.
Yeah, maybe. For those of you unfamiliar, Randall Munroe is kind of like he's a web comic artist, and he's wrote a couple of like sciencey books, and so it's a very like sciencey guy. He used to work at NASA, and so you should check him out. XKCD is his web comic. I'll put that in chat. It's really good.
Yeah, it also serves as a Dear Abby for mad scientists. Like, how many nutrients are in a human being? Things like that.
Yeah, he's pretty funny.
Really hilarious, to be honest.
Yeah. Kurzgesagt is also a really good resource. They do so much space stuff. I love all their space stuff. Like their black hole, all the stuff on black holes they do is so good. Okay. Yeah. Okay. Yes, let's go back to circle back. So yeah, they like asteroid belt and asteroids have so many resources on them, like to the point where some scientists think we could get to a post-scarcity society. What that means is that like, so the economic driver of like everything is that Earth has limited resources. So because of that, there's only so many of something can be produced. And so that's why the price like goes up if that's why like there's money and like you have to work and all the entire modern economy, right? But if there's no scarcity and there's just infinite everything, essentially infinite, it's not obviously not infinite, but it might as well be for our purposes. We don't need to do much of any, like there's no money, you don't have to work really, you can just have it because there's nothing wrong with just having it because you can't be there's no scarcity, there's literally everything. So it's a pretty cool idea that we might be able to reach it someday. We probably won't because people, but it'd be cool if we could.
Basically, the billionaires are going to get rich.
Probably what's going to happen, but if somehow that's not what happens and we do become post-scarcity society, that'd be rad. Because then there wouldn't be billionaire. Everybody would be a billionaire. Everyone would be in. There would be no money. So yeah, things would happen. Anyway, then also this is important because depleted Earth eventually will run out of resources. So we do like need somewhere to get them, right? Like that would make sense that if we ran out of something, we need yeah, you guys get it. Asteroid belt, a lot of things. All right, then also there's a thing in the asteroid belt called Ceres. It's like the largest dwarf planet in the asteroid belt, and so some people think it could be like a cool like mining base that we could do like things from. I just think that's rad that like we have a base on like Ceres. That'd be cool. Okay, yeah. So yeah, but Ceres, what's important is that Ceres is that like it's the largest dwarf planet in the asteroid belt. So yeah. All right. Then a population aspect of this. So some people think that are wrong, by the way. This is like a completely incorrect statement. So just, yeah. Think that Earth can only support so many people. And so those people are called neo-Malthusians because Robert Malthus, this guy pictured here, he in the like late 1700s, he said, oh, if the population of Earth keeps exponentially increasing like it currently is, we'll eventually hit a wall and everyone will die because there's too many people and not enough resource to go around.
But if there are more people, the people will grow more food.
Yep. Well, kind of, yeah. So he was like, people were like, oh my God, this guy's so smart. We're all gonna die. We need to do something about it. And then nothing happened. But
we have to kill people.
Yeah, we'll have to have a Thanos. But then eventually late in the 20th century, people thought that was going to happen again, and so they're called the Neo-Malthusians, and they're kind of still around a little bit, not really. But what matters is that people still kind of have an idea of like, oh, the Earth can only support so many people. This is wrong, because first of all, like, people can cut back on how much they consume, and then also usually people innovate ways to make Earth support more people, so it's really not that big of an issue. But yeah, this Robert Malthus guy, come on, there, no, there we go, he's wrong. Big X, no, he's wrong. So, but I mean, just simple like demographics is that the UN estimates Earth is only going to reach about 11 billion people anyway, which is about 3 to 4 more billion people than we currently have on Earth today. Wait, I'm just gonna. Yep, Richard, that is the concept of carrying capacity, and even then, so carrying capacity is a thing in ecology, saying that ecosystem will only support so much of a population of a certain animal. And even some ecologists are saying carrying capacity is wrong because animals will just adapt to their environment. So it is kind of a basic concept of ecology because it's a useful tool for ecology, but in practice, we don't know how relevant it actually is. And so, especially for humans, because we innovate and we change things, we're super adaptable. So, yes. Eleanor, you don't have to be so pessimistic, but yeah, probably. Oh, I guess, wait, never mind. I see what you're saying. Never mind. I thought you were saying something else. Yeah, Earth will definitely die before we will definitely die before Earth runs out of resources, probably. But maybe like water actually turns out we might run out of water well in like 2050. So we'll see.
It's not too long.
Yeah, it's not. It's kind of scary if you think about it. Anyway, and so
wait.
Yeah,
so what will we do then?
We're not gonna like run out of water, but what will happen is that certain countries will start having like very bad water problems that are already kind of having water problems. And so we don't know what we're gonna do. That's the main problem, is that we don't know. So yeah, like currently, oh, do we have a question? Okay, so currently my state, Minnesota, is experiencing a pretty bad drought, and a lot of the Midwest is, and so one of the worst droughts that we've seen, and so that is just, and that's been happening like for this past.
Couldn't you just go to other planets to find water? And then
Yeah, that's part of the argument, is that if we have
that takes time, and rockets aren't that big.
Well, you could also make an argument that like we have moved the entire population to another planet, but that'd be pretty hard. But yeah,
It'd be like impossible to get everyone, like all
impossible right now. Yes,
get like millions of people like on one spaceship and then ship them off to a planet that has no air.
Yeah, probably. Well, it might not. It might have air. You never know. Anyway, yes. So, well, let's get back to it. So, just water. Yeah. So we might run out of water, but that's not because of a carrying capacity. That's because we're systematically destroying the planet, which we'll get to in the next slide. Anyway, and so the UN just estimates we'll reach about 11 billion people simply because of demographics.
Can you post the slide in the chat?
What?
The slide in the chat.
What about the slide in the chat?
I just want you to put the link of the slide in the chat.
Oh, okay. Wait, how about are you part of the Google Classroom?
Yeah.
Okay, I'll just put the Google slide in the classroom.
Okay.
Anyway. Yeah, I forgot to do that last week. I always forget to do that. Okay, anyway. And so the demographic transition is that as a country industrializes, the birth rates will decline eventually because death rates will decline. So what happens is that as a country industrializes, death rates among like babies, infant mortality rate, that will decline. And so generally people have like a ton of children because the infant mortality rate is so high. So you have like 8 kids with the expectation like 4 of them are going to die. And so as a country industrializes, you're having 8 kids, but maybe eventually only 2 die, or 1 dies, or now none die, but you're still having 8 kids. And so that's why your population just explodes after you industrialize, or as you industrialize. But after a certain point, family structures change and you'll have less and less kids. That's why the fertility rate right now for a lot of the world is, a lot of the Western world is less than the replacement rate. So you're only having like less than 2 kids per couple. And so not having enough children to sustain the population. That's what's happening in Japan. And so that'll eventually happen across the entire globe, and so we'll reach max population of about 11 billion people. Angelina, we are doing a Kahoot after, yes. We are always doing a Kahoot after.
Yippee, a Kahoot!
All right. And then also the UN is like, hey, we're consuming at like 1.6 times. Western countries are consuming at like 1.6 times sustainable levels, and so it's really a consumption problem, not a population problem, because you can always have a large population that just consumes less. So, all right, yeah, Earth is dying. Yeah. So climate change. Yeah, we're all familiar with climate change. Yeah, so some scientists are like, hey, by the way, if we don't do anything by like now, Earth is gonna exceed like 2 degrees warmer, which for reference, the dinosaurs had massive inland seas that the North America, like the entire Great Plains was like a giant inland sea during the dinosaurs. Yeah, that was like 2.5 or like 3 degrees warmer than now. So just food for thought. So climate change, bad. And then we're also destroying a ton of habitats. If you saw my ecology class last time, yeah, for reference, we've destroyed 85% of the wetlands currently on Earth. So on Earth, all of the wetlands in existence right now are 15% of what used to be. Then we've also destroyed like 40% or something of like marine ecosystems. We can bring up the statistics later, but what matters is that we're destroying habitats at a record rate, to the point where the extinction of species is about 10 to 100 times other mass extinction levels. So the rate at which species are going extinct is exceedingly fast. And then we're also unsustainably consuming, like the UN said, we're about 1.6 times sustainable levels. So, yep. So, and that is Richard. That's about 10 to 100 times faster than like mass extinction levels. So like the dinosaurs, the dinosaurs extinction was slower than what we're currently experiencing. Just for reference. So you might be asking, why does this all care about space travel? Well, all I'm saying is that we can go to another planet. But yeah, so Earth might like die, so we kind of need a backup plan. And the current backup plan is that we fix Earth immediately. But nobody's doing that. So where are we gonna go? Yeah, so it's just maybe we might need to fall back on space, but we're probably gonna die before then.
You're supposed to live in caves and hunt these unknown species.
Exactly. And then also nuclear war might happen. You never know. The whole Taiwan thing might spill over. That would be not bad. That would be not good. And so if we have a backup like Earth that we're on, maybe if we destroy this one, the human race can continue on.
Well, technically, this is like setting off all the atomic bombs would be one way to get rid of global warming, because all the smoke would like cover the surface.
that we would indeed enter a nuclear winter, but that'd also be a nuclear winter, so I don't see the benefit. But yes, it would certainly reverse climate change in the
Yeah.
exact opposite direction of making it look always winter.
Wait, has a nuclear winter been like? Has it actually happened before?
No, because there hasn't been ever a nuclear war.
Has
So.
there ever been a nuclear winter before? Well, gee.
Yeah. So also, a nuclear winter requires a nuclear war where like hundreds to thousands of nuclear warheads are detonated, and to my knowledge, that is not happening.
To your knowledge, I mean, I don't think that's happened unless, I don't know, there's some kind
I guess
of
people know the
alien
consequences if they
racing.
do start a nuclear war.
Yeah, everybody knows what will happen, but it might happen anyway because humans.
Yep. Oh well. Mutually assured.
They can do that if they want to die.
Yeah. All right. And then Richard, I was talking. I was making a joke about the Taiwan issue currently spilling over, where China and the U.S. are kind of button heads over Taiwan. So I was just joking about that. All right. So then let's just like space exploration is super cool, and it's like kind of human nature to explore. And so here's a Neil deGrasse Tyson quote: "Space exploration is a force of nature unto itself that no other force in society can rival." Because humans, for the entirety of human existence, have looked at the stars and wondered, like, man, those are cool. What do those mean? Can we go up there? So humans, for like, we've always been fascinated by space. There's no way we're not getting to space some way or another. So it's just also really cool. Like, space is cool. That's just the entirety point of this is like, space is cool. Wouldn't it be cool if we were there? And it is cool. All right. And like, humans have, yes, Kiana, we are going to get to a Kahoot. We have like one more slide. A major thing, like, humans have always been explorers. We came out of Africa to spread across the entire earth. We explored the new world. Like, we have always been explorers. Space is the new way to go. It's the new final frontier. Then this is space is awesome. Anyway, the counter argument to why space travel does not really matter, that you hear a lot from, is that like, Earth has enough issues that we should probably focus on before like just abandoning Earth and going to another place. Like, for example, a lot of people really are mad that Jeff Bezos and like Elon Musk and the Virgin Galactic guy whose name Richard Branson, maybe. They're going to space, where all the billionaires are going to space, while like the rest of us kind of just sit here and die in like a climate changed Earth, and from like poverty and like homelessness. And so they're saying, why are you doing that when you could be focusing on helping societal problems? Which is valid. That's just the counter argument, is that the problems we currently face on Earth today are almost universally solvable as long as we put our minds to it and our resources to it, and that space exploration and space travel are taking those resources away and diverting them from problems that need attention right now but are not getting that attention. And so we need to focus on those, which, I mean, yeah, but in my opinion, I think the long-term effects of space exploration travel are like more outweigh it. But I do like recognize, yes, there are a number of problems that do need attention and are not getting attention. But how much of that is due to space travel is up to debate, because I would say very little of it. And I forgot to log into the Kahoot, so just give me a second, and we will get to the Kahoot promptly. Okay, and all right, let me quick while this is loading, I'll share audio. So this is going to be 8 questions, so we're going to have to rocket through it. Yeah. Let's see what disco is. I don't know if I'm a fan guy. Oh wait, okay, they have vocals in this one. That's so strange. Okay, wait, no, this is what I'm warmed up to. I like this one.
Can we wait a bit?
Yep. All right, I'm gonna start at 7:52.
Never gonna give you Apollo. Yes.
Like for the slides, can you like send them?
Yep, I'm gonna put them in the Google Classroom. So if I remember, I'll try to remember. Just harass me on Discord. My
Okay.
name on Discord is Orange Aeronaut. You'll see it.
I can't use Discord.
Okay, well then I'll try to remember it. Other people can harass me on Discord.
Okay.
Vedant, please do not spam me on Discord. But like for the purposes of adding the slides to Google Classroom, you can spam me for simply the purposes of adding the slides to the Google Classroom. How about you can have that, but not just like randomly.
Dude, the Mariana Trench is on Earth.
It is on Earth. So remember, this is the large igneous province, which is Tharsis. Olympus Mons is the tallest mountain in the solar system. Kind of a trick question there, because but yeah. Nice job, everyone. Ooh, fork rising to fourth. Fourth.
I can't see. What's the problem? I can't see anything.
The question is, what is the name of the currently ongoing mass extinction?
It's frozen for me.
Oh, rip. Yeah, I guess I should have pointed this out more. My bad. It's the Holocene extinction. The Great Dying is like the Permian maybe extinction, if I remember that right. And it's like pretty interesting because like it's the only mass extinction just called like something terrible. The Great Dying, because all the other ones are like scientific names, and then there's just like the Great Dying. Everything, just like everything died, I guess. It's funny.
Hey,
I
can you,
can't
like,
see the.
list
I can't.
So the question
Can't see
is,
the question.
I see it.
okay, wait, I don't, okay.
I see it now.
Okay, well, yeah, there's like 5 seconds left, so, I mean, my bad for whatever happened. Well, most people got it right. It's 11 billion. And remember, this isn't like, Earth is just gonna like reach this population. You can, oh, I don't know what happened. It just said participants can't see my application. Okay, I don't know what happened. So this is not like a carrying capacity. This is just like Earth is gonna reach it, and then we're not gonna really probably grow much higher than that, because that's just the way it goes from the demographic transition. So yeah. This is a poll, by the way. Both answers are right.
You just gave the answer away.
Yeah, I'm going to give the answer away because I want to see you guys' opinions on the poll. Okay. All right. Interesting results. Definitely interesting results. See, yeah, Jonathan, that's why I was trying to get, okay, whatever. Nice job. 8 out of 8 for 2 of the Rick Astley trio. And Eleanor
What you
rounding
could
out
do
a good
is
fourth.
third place and then second place and then first place would be never gonna let you down, Rick Astley.
Yeah, exactly. That's funny. All right. Nice job, everybody, on the Kahoot. Yes. 50% correct. Nice job, guys. That's almost passing.
Half.
All right. Yeah, nice job, everybody. Thank you, everybody, for coming. It was a great time. See you all next week. I'll hopefully remember to put the slides in the Google Classroom.